So today's lesson will be easy. The reason why today's lesson will be easy is you did it last year. Remember how I told you solving radicals was easy because you did it last year? Solving rationals will be easy because you did it last year. So x over x, so solve x over x minus 2. X minus 2 plus 6. If they asked you how you could solve this in your calculator, we could do y1 and y2 right now, and what would we look for then? X of the intersecting point. Okay, what if I moved the x over and set it equal to 0? Then I did y1, y2. Then you'd be looking for the x-intercepts. Okay, so if it's equal to 0 and you do y1, y2, you're looking for the x-intercepts, right? Or if it's y equals, you're looking for the x-intercepts. If it's set up like this, y1, y2, then you'd be looking for the x value of the intersecting point, right? Very different. They ask that like usually one question somewhat, like once every 2 diplomas, and they'll ask a question somewhat like that because they're testing whether you can use, if you know how to use your calculator, because they can't see it, so they'll ask you questions about it. Okay, so we're going to go solve this. The very first thing we have to do is state non-permissible values. That's going to come back to your head very quickly. Non-permissible values are the values that you can't have, the values that can't exist. And with rationals, they're the values that would make the denominator 0. Because we can't divide by 0, right? Nowhere in the world can we divide by 0. It's against the math rules, math laws. So this denominator is 1, this denominator is 1, this denominator is x minus 2. So what can't x be? 2. So if you wanted to, you could go x minus 2 can't equal 0. So x can't equal 2 when you solve it. So why is that important? Well, that's important because that is going to be an asymptote for you tomorrow and the next day. But also, it's going to be something you need to check at the end, because if your solution is 2 and you pick that on the diploma, you'd be wrong because it can't actually equal 2. You said that already. Okay, so what I always do is as I'm working along, I take my MPV and I write it down here so that at least when I'm done solving it, I remember to check. So I don't just leave my MPV at the top. You could arrow it down, or you could write it down there, whatever you need to do, or you could star it, or whatever you need to do, but people forget to check, okay? You have to remember to check with radicals by checking it back in. You have to remember to check with rationals by seeing that it's not the MPV. So our goal here is to solve. The word solve means find out whatever the heck the variable is equal to. So in this case, the variable is x. I want to know what it equals, correct? So I want to get rid of the denominators because in order to solve, I want my denominators to go away. The only way my denominators can go away is if I can get them to cancel. So I always look at my denominators and I say, can I factor them, or can I take out a GCF to make them more simple? These denominators are pretty simple, so you can't make them more simple. I put brackets around anything that has plus or minus signs because I know that they're attached. So x minus 2 is attached. The only way it's going away is if there's another x minus 2. You can't just like say this denominator here was an x. You can't just put a negative 2 and then it would match the other one. Okay? Because in order to get common denominators, you're multiplying. And if you have an x and a minus 2 side by side, that's actually negative 2x because you're multiplying them. Okay, so our first goal is to get rid of the denominators. So I'm going to multiply all of them by this denominator in the numerator. And as long as I do it to every term, I can multiply just the numerator by it. But I have to do it to every term. So the x minus 2's cancel. Now, the only other denominator I have left is a 1. So do I have to multiply everything by 1? No. Can they just go away? Yes. If you really, really, really want them to cancel off, multiply by 1. Doesn't matter. But the 1s don't matter. Okay. Now we're good. Now we can just solve. So we have x plus 6 times x minus 2. We just write what's left over. Equals x times x minus 2. Right? And now we can just distribute and solve for x. So we have x plus 6x minus 12 equals x squared minus 2x. How do we solve when there's an x squared? Set equal to 0, move everything to one side. These are all correct answers. So I'm going to minus the x minus the 6x and add the 12. X squared minus 9x plus 12. Now, is there anything that multiplies to give me 12 and adds to give me negative 9? So how would I have to get my solution? Quadratic. So x equals negative and negative 9, so 9. A equals 1. Nine plus or minus the square root of negative 9 squared minus 4 times a times c all over 2 times a. X equals 9 plus or minus square root of 81 minus 48 over 2. $33, I think. Can 33 reduce? It's just 3 and 11. Neither of those are perfect squares. So that would be my answer. What happened if under the square root sign I got a negative number? There's extremes, no solutions, right? So if you actually looked at that radical graph, if you moved it all to one side, set it equal to 0 and put it into your calculator, it would either be completely above or completely below. But rational graphs are very hard for that to happen because they do this. They usually curve, right? But it could happen if the asymptote is on the x-axis, right? Okay. So that was a more simple one that we didn't have to do anything to. We just had to multiply the denominators all by it. What if I give you one like this? Example 2. Solve. Three over 5x minus 7 plus x equals 1 plus x squared minus 4x over 7 minus 5x. What do you notice about the two denominators? The same, but one of them has a negative 1 in it. So I could just go like this. Take the negative 1 out, and then I would have 5x minus 7. Do you agree? That negative 1 in front is just like having a negative sign, correct? Can a negative be on the bottom, on the top, in the middle? Can you move that negative sign? Yeah. So you have two options here. You could multiply every term by negative 1, 5x minus 7. Or you can move the negative to the top and distribute it into your two terms. Those are your options. Which would you rather do? Take the negative to the top and distribute it through. So this would become negative x, positive 4, and then this would be gone because I put the negative 1 up. Yeah? If you don't want to do that, if you second guess yourself on some test, not a problem. Just multiply all the numerators by negative 1, 5x minus 7, all of them. Okay? It would do the same thing because it'll cancel it off here and you just end up with a negative here. So I just took the negative and I moved it up and then distributed it in through the top. Okay. So now our only denominator we have to get rid of is 5x minus 7. So we're going to multiply all the numerators by it. And then you just write what's left over. What if there was a minus sign here instead of a plus sign? It'd be positive x squared minus 4x. You'd have to remember to distribute the minus sign through all the terms behind it because you're subtracting the whole thing. So we get 3 plus 5x squared minus 7x equals 5x minus 7. What can we do now? Make it all equal to 0. I'm going to move it over here so I have a positive x squared minus 5x. And this one actually factors, which is nice. Multiplies to give you 60 and adds to give you negative 16, negative 6, negative 10. Could have reduced it too and then done it, but what do we have to remember to do at the end? Check it. So we have x equals 5/3 and 1, and we know x can't equal 7 over 5 because you would just take 5x minus 7, can't equal 0, 5x can't equal 7, x can't equal 7 over 5. You just solve for it. So these are good. Now, could you type the original into your calculator and just find out where they intersect? Sure. You'd have to be very watchful with your brackets because you'd have to have a full bracket around here as well, and then you'd have to have brackets around this binomial. And you have to have full brackets around this one and brackets around each of the binomials, right? So you have to make sure you bracket it properly if you're going to try and find it with your calculator. Okay, then one last one. Actually, two. Mm-hmm. 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 You took it to... You're good? Okay. Because it should get you the same one, because this 2 out here affects the y-intercept, but it doesn't change your x's. Okay. Reason why I gave you 2 different ones here. This one here has an x and an x minus 2 and a 1. You have to multiply to get rid of them, right? So if I multiply by negative 2, I'm going to get negative 2x. Is that the same as x minus 2? No. Can I just cross the x off the front of it and then it just goes away? No. You actually have to multiply by each of them. Okay? So I'm going to multiply by x each term. Then this x is gone. But it does nothing to the x minus 2. It doesn't cross the x off on the x minus 2 at all. They're totally different things. Then I'm going to go behind and multiply by x minus 2. Then this one cancels. And the 1 just goes away because it's a 1. So you actually have to multiply by both, okay? You can't just multiply by a negative 2 somewhere randomly and it gets it to go away, which people do some crazy math when it's like this. When I see an x and an x plus something or x minus something, I'm like, ugh. If they're totally different, you would never do it. But when they're that close, you guys try and multiply by like negative 2 or something. So our NPVs are x can't equal 0 or 2. We should have stated those before I canceled. And we write what's left over. 2 times x minus 2 equals 3x times x minus 2 minus 7x squared. Distribute. 2x minus 4 equals 3x squared minus 6x minus 7x squared. 2x minus 4 equals negative 4x squared minus 6x. And then I'm going to move everything to the left side because I like having a positive x squared to deal with. It's just my thing. So you get 4x squared plus 8x minus 4 equals 0. And you can take a 4 out. Or you could just factor it right there. It doesn't matter. It's not going to change your x-intercept. X squared plus 2x minus 1. We factor that? No. If it was a plus 1 at the back, we could. But because it's a minus 1, we can't. So x equals negative b plus or minus the square root b squared minus 4ac all over 2a. If you had used the 4, 8, and the negative 4, it would still work. You just end up simplifying more at the end, canceling off more terms. So if you use this one, this is your a, this is your b, this is your c. If you use this one, this is your a, this is your b, this is your c. They'll get the same answer. You just have this one. If you use this one, I'll have to simplify at the end. So you're going to get x equals negative 2 plus or minus the square root of 4 plus 4, which is 8, over 2. X equals negative 2 plus or minus 8 breaks into 4 and 2. So 2 root 2 over 2. Take a 2 out, and you're left with negative 1 plus or minus square root 2. Check our answers to our NPVs. Our NPVs are 0 and 2. That's not 0 or 2, so we're good. And then I picked the last example. Why would I pick that one? Why is it different? Every single example has been a little different. you can take an x out of the denominator, and then we have two denominators that actually match, right? So we'll have 2x minus 1 over x minus 1. You never simplify your numerators. If you do, you're just going to end up distributing back into them. But you do simplify your denominators. Plus 4 over 1 equals x over x minus 1. I'm going to put that in bracket. Now, I'm going to multiply all the numerators by x and x minus 1. And technically, I could do 1, but it wouldn't do anything. So I don't. So x and then x minus 1. Before I canceled them, I should have said x can't equal 0 or 1. Then I just write what's left over. And this one can factor. What multiplies can be negative 3 and adds can be negative 2, negative 3 and positive 1. Let's sketch. Do you see how easy it would be to pick that answer, though, in the diploma? Because they'll have it, right? We don't want that to happen. That would be stinky. So in the homework, it says use a graphical method. Try once to try and graph it. You can check by graphing if you want to, but most of the time you're going to be doing this algebraically anyway, so don't just like get so used to your graphing calculator. Plus half the time, it's hard enough to just type it into it properly. So if it says use a graphical approach, you can do it however you want, but that'd be my suggestion. Page 465.